Hello, Fifth Hour. I just had an email that had a question on today's questions, and so I figure that usually when one student has a question, many others might have the same. So the question was, how big and bright is our star compared to other stars? And then the other question was, what determines how long a star will stay on the main sequence? Okay, so I'm going to show you where that is in the video. I know it's right at 25.
Hi, I'm Emerald Robinson's own sun. But as far as stars go, the sun is considered average.
Our sun is considered average. Okay, so it's not like a really, really small star, and it's not one of the many, many huge stars we have in our universe. It's just very average as far as lifespan, size, and rate of nuclear fusion. Then the other question was what determines how long a star stays on the main sequence? Remember, that's that stage that is 90% of a star's life. So we'll go here.
Dwarf stars. The duration a star spends on the main sequence depends primarily on the amount of fuel it has to consume and the speed of its reactions. The larger the star, the quicker the fuel consumption.
So what she said there was that it depends on the amount of fuel it has and how quickly it's burning it. Um, Large stars burn their fuel more rapidly, and so they usually have a shorter lifespan. Kind of like a really big gas guzzling truck is going to go through gas at a much faster rate than a Prius. There's my analogy for the day. Anyways, hope that helps. Talk to you soon. And by the way, if you ever have questions like that, just email them and I'm happy to post a video.